Hi guys, and welcome to week 6 and the final week of the Advanced Emmbrook School Mathematics summer progression from year 6 into year 7. I hope you've enjoyed what we've done so far. Sorry for the delay this week, I've been away, but in fairness, don't start until next Thursday, so hopefully this will be a nice little timely addition to the last remaining week of your holiday. Okay, so as always, here are our 10 questions. Some of them a little bit different this week, but all of them build upon the work that we've looked at so far. So if you want to pause the video now and have a go at your final 10 questions, then I will flick to the answers in a moment. Okay, so here are your answers, and once again, for the last time, if you go through, see if you can find any mistakes that you made yourself, looking into your own work, any numerical calculations that might have gone wrong, and see if you can work them out. And if not, I will go through them now, cross them off as I go, so you can flick through the videos to find the ones that you want. Okay, so the first one then, round 0.6529 to 2 decimal places. Nice easy warm up, hopefully got that one right. So we just counted. Here's our first decimal place here. Let's change to the favorite pen. And here's our second decimal place there. So that's 0.65 as it stands. But remember, when we round, we look to the next decimal point, because really what we're saying is, if we're going to round to 2 decimal places, are we closer to 0.65, or in fact is our number a bit closer to 0.66? What would be in the middle is 0.655, and in fact we're down at 0.6529, so that's going to be roughly here. Okay, so because this digit here is less than a 5, so digits 0, 1, 2, 3, and 4, we round back down to the 0.65 for 2 decimal places. Okay, right, so for question 2 then, do this slightly differently, perhaps from how we've done it before. So you've done some expanding brackets, and if you've expanded those brackets and solved the equation, good, well done. If not, here's another way to think about this. Okay, so this is 5 lots of a bracket, 2x minus 3, and that's meant to give us 30. Now, we spent a lot of time boxing things in equations, and actually these brackets work quite nicely to do that again here, because it's 5 lots of whatever this thing is here, 2x minus 3, and the bracket is 30, then if we divided that by 5, here's this balancing of the equation, doing it to both sides. And rather than having 5 lots of the bracket, we simply have 1 lot of the bracket, so we just denote that as 2x minus 3. Don't need a bracket with a 1 times, it means the same thing. Of course, that's going to equal 6. So 5 lots of the bracket are 30, well then 1 lot of the bracket must be equal 6 divided by 5. So that works nicely if this number here being multiplied by the bracket goes into or is a factor of 30, or the number that it's meant to equal in the equation. So now we can just read it like a sentence. 2 lots of a number minus 3 is 6. So if we add the 3 back on, then we can say that 2 lots of that number must be worth 9. And then if we divide by 2, 1 lot of the value of x that we're looking for must be 4.5, which is half of 9. Okay, so for question 3, it's an important question in maths, especially at your level, because we need to make sure that we get our order of operations correct. Okay, so in maths, we don't just read from left to right. We also interpret the operations that are there and give them an order. Okay, so I think we've spoken about it before, and if you want to look it up, it's called big maths. You'll find it all over the internet. So this tells us that we do brackets first. Okay, there aren't any. Then any indices, there aren't any of that. So this is an index number here, so 2 to the power 6. So we do that operation next if it was there. Then any division, there's none of that. And then any multiplication. So we will do that because we come to this. So let's do that here. So we scan through our calculation. Here is our multiplication here, 4 times 3. So let's replace that multiplication with its actual value, which is 12. And then let's rewrite this calculation. So now it's 20, take away 12, add 15. So if we keep going now, you can actually do addition or subtraction in any order. It doesn't make a difference whether you add a number and then take a number away, or take away a number and then add on it. It gets you back to the same bit because you're just moving up and down the number line. Okay, so let's do this in order now. So 20 take away 12, well, that takes us down to 8. And then if I add 15 back on, 15 add 8 takes us up to 23. Okay, so if you can remember this rule coming into, if you haven't seen it before, coming into secondary school, very useful to come across that very quickly. Okay, so express 18/5 as a mixed number. What does that mean? Well, if we drew a circle, then within our circle, normally, we can fit 5/5. There we go, fifths. Not too bad. There we go, so they should all be equal. So we have 5/5 in every one whole. So this would be equal to 1. I have 18/5. Okay, so way more than I would fit in one whole. So the question is, to express it as a mixed number, how many holes do I fill? And then do I have any fifths left over? Okay, so it would be 5/5 for one hole. And then I'm sure you could imagine that 2 holes would be 10/5. So I could just draw exactly the same circle again. And in fact, if I went again, that would be 15/5. So far I've got 3 holes. But I've used 15 of my fifths, but I've got 18, so I've got 3/5 left over. So I drew a circle. I wouldn't use up the whole circle. I would only have 3 of those fifths left over. Okay, so when we write it as a mixed number, I want to know how many holes did I use up. I used up 3. And then I had 3/5 left over. So there we go, there's our mixed number, 3 and 3/5. A quick way to do it can simply be, how many times does 5 go into 18? But really we're asking how many fifths go into as many holes as we've got. So 5 goes into 18 3 times. So there's our holes. And how many left over? How many fifths left over? Well, 3, because we've got to 15, and then 16, 17, 18. Okay. Right, so for question 5, we want to convert litres to millilitres. So of all these questions, I'm sure you know what you're doing, but nonetheless, let's write our initial conversion. So 1 litre, remember you can just use things like Google to check this, is in a ratio or equivalent to 1,000 millilitres. Okay, when the units aren't the same, we shouldn't really use an equal sign, even though we would say that they are equal, but they will work in this ratio. So now I've got 6.2 litres. So that's 6.2 times bigger. I'm crossing them off, I might get in trouble. There we go. So then I need to make this 6.2 times bigger. So that will give us 6,200 millilitres. And again, if we're not sure if we're going to times 6.2 by 1,000, then we want to move that 6.2 3 places to the left of the decimal point. So move that over and you get to 6,200. Okay, evaluate 2 to the power of 6. We've looked at this, but let's write it out anyway, because if we've got it wrong, that might be our interpretation of what this means. So it just means multiply, it's the quick way of writing, multiply 2 by itself 6 times. Okay, so I've got 2 times 2, so that's 4, times 2 again, so we're doubling, that's 8, times 2 again is 16, times 2 again is 32, and then times 2 again gets you to 64. Okay, so that's our answer for 2 to the power of 6. This is a useful calculation if you want to do computing, and I'm sure you'll see why when you get to year 8, I would imagine. Right, what is, and again, it's really useful, actually, we'll go on to video 2 for this one.